Okay, a couple more balancing redox equations with our Norso steps. So this one is H2O2 becomes water and oxygen. Now, this is going to give you trouble unless you can remember it as a strange exception for oxygen with oxidation states. If you go into this and you try to put in the +1 and the -2 like normal, you're going to find that there's just no way to make it add up, and so it doesn't add up to 0, so something is off here. Now, you could think that maybe hydrogen could be +2 in order to be balanced, but hydrogen only has one electron, and therefore it's impossible for hydrogen to become a +2 oxidation state. This is the strange exception for oxygen, where it's bonded to itself with a single bond, and therefore it's called peroxide. Anytime you have peroxide, the oxygen ends up in a -1 oxidation state, so it has some unique chemistry and some unique redox properties as a result. On this side we've got +1 and we've got -2, and over here we've got the element oxygen, which is 0. So this is kind of a interesting redox equation because, well, for a couple of reasons. We've got oxygen in all of its different oxidation states, and we've got oxygen -1 getting both reduced and oxidized. So what do I mean by that? Well, hydrogen doesn't change. So the oxidation here is that O -1. When I'm doing oxidation, it's going up. Its oxidation state is going up. So that means O0. And that's going to be a 1 electron change. But when I do subscripts 2 and 2 for the O2 gas and the H2O2, that becomes 2 electrons. Now I'm going to do the reduction. The reduction, where we have a decrease in oxidation state, is from O-1 to O-2 in the water. So O-1 is getting both oxidized and reduced. Okay, now I have to come back and add in a subscript. Oh, I forgot my own step, which is to first do that there's 1 electron change when we go from O-1 to O-2. So check that electron first. Now if there's a subscript, add it and balance it. Okay, so I've got 2 electrons being lost, I've got 2 electrons being gained. So I need to now build out the rest of the equation. So the O2 on the left is coming from H2O2 in both half equations. So what's interesting is that the H2O2, as the oxygen minus is being both oxidized and reduced, the H2O2 is actually reacting with itself and acting as both the oxidizing and the reducing agent at the same time. So that's a little wacky. It's a bit of a weird example. And you can bet the IB gives it every now and again. Okay, so now I've got H's on the left. Let's balance them. There are 2 O's on each side. There's 2 H's on the left, so let's put 2 H plus on this side to balance it. Now in this one, I have to build back the water. And I scribble out my oxidation state now. I've got 4 hydrogen on the left. I only have 2 from this H2O2. That means I need another 2 on this side. So those are the 2 half equations. H2O2 becomes O2 plus 2 electrons plus 2H plus. That's the oxidation half equation. The reduction half equation is 2H plus. Let's move that down. 2H plus 2 electrons plus H2O2 makes 2 water molecules. And when you put it all together, the H plus and the electrons cancel, and the H2O2s actually combine. And so you get 2 H2O2 makes O2 plus 2 water molecules. And that is the overall balanced equation. Now, let's skip ahead and let's try probably the most challenging one, or one of the most challenging ones you could possibly get. Okay, we can do it if we pay close attention and we follow through on our steps, if we're careful. So ethanol reacts with acidified dichromate ions. So here are the dichromate ions, and they said acidified, so that means H+. We're going to make ethanoic acid. We're going to make Cr3+, chromium 3+ ions, and we're going to make water. Okay, now I need to put in my oxidation states. So I've got -2, I've got +1, +6. That means I need -4, I need -2 on that original carbon. I've got -2 on the oxygen, -14 needs to add up to -2, so I need +12, so +6 on the chromium. The chromium on the right is +3 given to me, and now I've got this other one to deal with. I've got -4 from the oxygen, I've got +4 from the hydrogen, therefore 0 from carbon, and the other hydrogens and oxygens are in their normal states. So what's changing? The carbon is going from -2 to 0. That's an increase. That's oxidation. So I've got C -2, C0. That's going to be 2 electrons given away. I'm going to check for subscripts. That becomes 4 electrons. I then go to the reduction, and I see that the chromium goes from +6 to +3. That's a gain of 3 electrons. This CR has a subscript, so I need to add a coefficient, and I need to double my electrons. Now I have 4 electrons in the oxidation, and I have 6 in the reduction. The lowest common multiple is 12, so let's go ahead and make them 12. I need to multiply the first one by 3, and I need to multiply the second one by 2. You can already tell, it's starting to get messy. Okay, now I've balanced the electrons, I've double checked for subscripts, I've done Norse. I now need to add everything else back in and balance the equation. So if I put let's just scribble that out, H6O over here, H4O2 over here. Now let's be careful and count. I've got 3 oxygen on the left, I've got 6 on the right. Therefore, I need 3 more on the left. Okay, I count hydrogen. I've got 6 H from the water. I've got another 18 from the ethanol molecules, so that's 24. And I have 3 times 12 over here, so I've only got 12 there. So I need another 12 H plus on the right. Okay, top equation is done. That's the oxidation half equation. I now rebuild this one. There's the 7O2 minus. That is 14 oxygens, and there's none on the right here, so I need 14 water molecules. There's no hydrogen on the left, and there's 28 on the right, so let's add 28 hydrogen on the left. Okay, reduction half equation is now done. Now putting them all together, I've got a lot of cancellation happening. I've got 3 waters on the left and 14 on the right. That leads to 11 water molecules on the right hand side. And I've got 12 H plus and 28 on the left. That's going to lead to 16 H plus on the left hand side. The other ones carry down, the electrons cancel out. Again, it doesn't matter what order I write things in the equation because they're all being added. And now I've got the overall balanced redox equation. I can see that the ethanol undergoes oxidation and therefore is the reducing agent. And I can see that the chromium plus 6 is what's undergoing reduction, so the chromate here, dichromate, is the oxidizing agent. A metal with lots of oxygen on it is a good candidate to be a strong oxidizing agent. And so that is about as annoying and complicated and tricky as a balancing redox equation can get, but with careful attention to the steps and balancing, you can do it.